One that's, the remainder doesn't equal 0. Now all I'm going to do is use the same polynomial on the top, so the same numerator, and in the bottom all I'm going to do is change it from x minus 2 to x plus 2, so it's not a factor of the top, right? The top quadratic equation. So your question would be, or the expression that would give you is the yellow guy. So our top divided by that, so they would say simplify this expression, right? Or do long division on this expression. If they said simplify, you would factor the top and see if the top factors of this guy, if any of them cancel out this guy, then you're done. Now, we already know that the factors of the top guy, there is none of the factors of the top guy is equal to x plus 2. It's equal to x minus 2, so they can't cancel each other off. So we can't simplify this just by factoring the top, because the factors of the top do not equal the factors of the bottom. That means the remainder is not equal to 0. When we do the long division, we're going to find out the remainder does not equal 0, right? Which means the bottom guy is not a factor of the top guy. So if they say simplify this or do this long division, we're going to have to do the long division, because we don't know synthetic division yet, but we will soon. Okay, so let's do the long division. Long division. What we're going to ask ourselves is this: what are we going to multiply x by to give us negative 3x squared? Well, we're going to multiply x by negative 3x, right? Because negative 3x times x gives us negative 3x squared. And then we're going to see what the rest of it looks like, right? Because the only thing we care about during the long division process is matching the first number here with the first number here. And one thing to keep in mind, and again, this should be a given by now, is whenever you're giving polynomials, you have to have them in descending order, right? Your highest order goes first, and then you go down from there. So if they give you, an expression like this, that's all mixed up. You got x to the third and x to the 5 plus x to the 2, or whatever it is. They're all in, not in the right order, descending order. You have to put them in descending order. Any polynomials you get, and that's a given rule, any polynomials you get, any functions you get, you put them in descending order, okay? And that's a given. So if they try to trick you by mixing your expressions up, the orders up, take the x's and put them in descending order, okay? And these are single variable functions that we're really concerned about right now. Multivariable functions we'll get into, later. So what are you going to multiply x by to give you negative 3x squared? You're going to multiply it by negative 3x. So you put your negative 3x on top of this. Each term follows each other. You should keep things in order. So negative 3x goes up here and multiplies this guy and multiplies that guy. Negative 3x times x is going to be negative 3x squared. Negative 3x times 2 is going to be negative 6. Now, again, this is subtracting the bottom from the top, so it would be minus negative 3x squared minus that guy minus negative 3x squared, and 5x minus negative 6x, right? Now I don't like all those minuses all over the place, so I'm going to change the sign of that guy, change the sign of that guy, and I'm going to add them. They were both negative, so they both turn into positive, and I'm going to add them. So negative 3x squared plus 3x squared is just going to be 0. 5x plus 6x is going to be 11x. That guy cancels that guy. So usually what I end up doing is I don't put 0 down here, I just kill them, right? And 5x plus 6x is going to be 11x, and then we're going to grab this guy and bring it down. So we've got positive 2 coming down. And always remember, the sign in front of the number always goes with the number, right? So positive 2 comes down. So again, the question that we're going to be asking ourselves is, what do we multiply x by to give us 11x? We don't care about this guy right now. This guy's going to work itself out, right? If it doesn't work itself out, it's just going to have a remainder. So what do you multiply x by to give you 11x? Well, you're going to multiply by 11. 11 times x is going to be 11x. 11 times 2 is going to be 22. Change the signs and add them. So that becomes negative 11x minus 22. 11x minus 11x, they kill each other. 2 minus 22 is negative 20. Now, you can stop doing the long division as soon as the power over here is less than the power up here on your first term for your divisor for whatever's in the denominator. you're done factoring, right? Or you're done doing the long division. So if this was an x squared, right? If this was x squared plus 2, and you know, you went through your thing and you had an x term in the bottom here, you would have to stop, because if this was an x squared and you had an x over here, this power over here is bigger than this power over here, and you can't go any further, right? So as soon as the power on the first term in the denominator becomes bigger than the power of wherever you've gotten to in the long division, you're done, right? What we're going to do right now is write this in the form of the division statement, okay? So I'm going to forget about writing the x's. It's just going to be p is equal to q times d plus r. So p is the top, our numerator. Q is our quotient, this guy up here. D is the divisor. And r is our remainder. You see all that? We sort of had to go on a slant because we're hitting this guy. Should have written down further down here, right? Anyway, so basically what we have is our product, this guy, is equal to that guy times that guy plus that guy. So this, the numerator, is equal to negative 3x plus 11 times x plus 2 minus 20, right? And what that means is, if you FOIL this guy out and subtracted 220, you would get this guy back. So we broke down this guy into things multiplied together and, you know, whatever the remainder is. So we tried to factor it. We basically wrote this guy in a different form and we got this guy, right? So both of these guys, this guy, this side is equal to this side, okay? Now, there are reasons why we're going to do this, or there are reasons why we do this. One of the ones, just as a teaser, what this means is if your x is equal to negative 2, because this would be x plus 2 is equal to 0, and you bring the negative 2 over, when your x is equal to negative 2, y is equal to negative 20. When your x is equal to, you bring the 11 over, you set this equal to 0, and then do your division. If you set x is equal to negative 11 over negative 3, which is 11 over 3, if you sub that into your original polynomial, your y is going to be negative 20. So these guys are actually coordinate systems that we have. There are 2 points on, and this guy's a parabola. Okay, so let's just lay this out, and we'll do the graph over here, and you'll see where the points lie. So if you actually rewrote this guy, the q and the d, as x equaling something, right? So you took your quotient and set it, equal to 0 and solve for x. And you took your divisor, x plus 2, set it equal to 0 and solve for x. What you would have is, you would say x plus 2 is equal to 0 and solve for x. So you got x is equal to negative 2. And you would set negative 3x plus 11 equal to 0 and solve for your x, and you got 11 over 3. If you took those, x is equal to 11 over 3, and subbed it into the top, the numerator, what that would give you is your remainder, your y, for a graph, right? So these are actual coordinates that you just figured out. So when x is equal to negative 2, y is negative 20. When x is 11 divided by 3, y is negative 20. So if we put it on a graph here, we'll just put it on a graph here, and negative 20, well, our x-axis is going to be up here, and we're going to graph it down here. For a quadratic, for a parabola, when you got a negative sign here in the front, in the highest order, in front of the x squared, that means the parabola opens down. So what we have for our coordinates is these are 2 coordinates on the parabola. Negative 2 and negative 20. X is negative 2, y is negative 20. When x is 11 over 3, y is negative 20. So our parabola goes up and comes down again, and those are 2 coordinates that we have, negative 2 and negative 20, which is negative 1 is which one? This one. So that's negative 2 and negative 20, and 11 over 3 is that guy, right? Now, we know by factoring that guy that it has factors, right? So if we're looking at that quadratic equation right there from the the quadratic formula. If we look at the quadratic formula, the discriminant that we've talked about in the quadratic formula section, the discriminant of that is positive, is greater than 0. That means when you take the square root, where it's x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a, b squared minus 4ac, that's positive, greater than 0, so you can take the square root of that. So you're going to actually have two x-intercepts, and we already knew that because we factored that guy, right? So we factored that. We know it's got two factors. That means it's got two x-intercepts. That means the parabola crosses the x-axis and comes down. And from before, we know exactly what the factors of that thing are. The factors of that thing are x is equal to 2 and x is equal to negative 1 over 3. So in the positive side, this guy goes up and crosses at x is equal to 2. It hits it. So there is another point that we know for the parabola and goes up. The other one is x is equal to negative 1/3. So it goes up here. This guy goes up here. I should have drawn a little bit closer, and goes up here, right? Another coordinate that we can find, later on we'll get into it, is the y-intercept. And the way you find the y-intercept, all you do is just set x is equal to 0. And the y-intercept is just going to be 2. Okay. So anyone who's done graphing parabolas knows pretty much what I'm talking about. Hopefully knows what I'm talking about. And if you don't, hopefully this is a pretty good, sort of a lesson of how, what all these coordinates mean, right? So let's throw on our two factors up here, our x-intercepts, and graph that too. So our parabola is going to look something like that. Hopefully you can draw it better than me, because that should be, looking like a parabola instead of going like a little bulge. So that's our parabola, right? And again, all of this information we got to here just by doing our long division. Our long division, when we got to the remainder, knowing that all the remainder is, if there is a remainder, it means it's the y-coordinate when x is equal to whatever this is, and x is equal to whatever that is, when you set them equal to 0, when you solve for them, right? So there's a lot of things going on here. And, usually when this is taught, all they teach people is, do the division, do the long division, you get down to here, and, what does that mean, right? Well, that means that's the y when x is equal to either, well, for this guy anyway, you set the denominator equal to 0 and you solve for x, so x is equal to negative 2. So when x is equal to negative 2, y is negative 20, whatever the remainder is, right? And the quotient gives us another point. Now, for parabolas, there's an axis of symmetry going down here, and we'll talk a lot more about this. There's a lot of things with parabolas. There's special things that you need to know about it, right? There's symmetry with it. If you cut yourself down the middle, hopefully this ear is the same distance from your center as the other ear, right? And there's symmetry in a lot of things in life, and parabolas are one of them. There's symmetry to parabolas. If you cut the parabola down straight down the middle, it's symmetrical. This side is symmetrical to the other side. If you want to find the axis of symmetry for a parabola, all you do is add that, negative 2 plus 11 over 3, and divide it by 2. And that will be your axis of symmetry going straight up. So if you want to find out what the y-coordinate is, what the vertex of a parabola is, all you got to do is find the average of those two guys, right? Once you find the average of the x's, you plug it into your numerator here, your product here, right? Your dividend here, right? And once you plug that x value here, the average of those two guys, whatever it spits out is the y-coordinate for the vertex. We'll do another long division, a little bit more complicated, and again, maybe we'll go ahead and graph it as well, but I doubt it, because it's going to be a higher order, and we don't want to go that far yet, right? We will later, but we don't want to go that far yet. So let's do another one, and then when we get into synthetic division, we'll come back and we'll use synthetic division for these guys as well, and you'll see that we get the same answer.